You end up with the derivative of tangent is indeed what? Secant squared x. Now I did ask some of you if g of x was equal to cotangent x. Here's one you also have to memorize. What's the derivative? Anybody remember? Negative cosecant squared of x. Negative cosecant squared of yes. Remember what a to the log base a of x is equal to? Do you remember what that equals if you have a to the log base a of x? Anybody remember? Anybody want to guess? Just take a wild guess. It actually equals x. It equals x. That's something that's true about logarithms and exponents. I'm not going to prove that, but that is true. Believe that for now, but a can be anything as long as it's the same base. So what does 7 to the log base 7 of x equal? X. Doesn't matter what it is as long as it's the same base. So here's the thing. It can be any number you want it to be, so I'm going to make it the number e. So I'm going to make it this. E to the log base e of x is equal to x. What does log base, how do we write log base e? What does that mean? Or how do we write it? ln. So we know that e to the ln of x is equal to x. That is true. Golden rule of algebra states that what you do to one side you have to do to the other to keep it a true statement. Let's take the derivative of both sides. Side note, what's the derivative of 7 to the x? Do you remember what the derivative of 7 to the x is?
7x ln 7.
Yeah, it's ln 7 times 7 to the x. Everybody with me on that? So over here, what's the derivative on the left? What's the derivative of e to the ln x? That's going to be ln of e times what? E to the ln x. But then you have to multiply by something. You have to multiply by the derivative of ln x. Why do you have to multiply by the derivative of ln x? Because of what rule? The chain rule. Over here, if I had, what's the derivative ddx of 7 to the x squared? What's that going to be equal to? That's going to be ln 7, 7 to the x squared times what? Times 2x because of the chain rule. So over here, what's the function that's in the exponent? ln is in the exponent, so we have to put the derivative of ln x on the outside. I'll show you this all. It looks like it's getting worse, right? It won't. Just watch. What's the derivative of just x on the right side? What's the derivative of x? 1. So this equals 1. You with me so far? What does ln of e equal? What does this equal?
1.
That is 1, so we can just not have it written there. So what do we end up with? We end up with e to the ln x times the derivative of ln x. We don't know what that is yet, is equal to 1. Oh, what is e to the ln x equal to? What does e to the ln x equal? It equals x. So this is x times the derivative of ln x is equal to 1. What should I divide both sides by? X. So the derivative of ln x is equal to what? 1 over x. The derivative of ln x is 1 over x, everybody. Yay! That's just something you need to remember. That's something you need to add to the list of things you have to remember. We are now going to use these rules combined with the product, power, chain, and quotient rules. These are new things we can use in the power, product, chain, and quotient rules. So we know, what's the derivative of tangent? Do you remember what the derivative of tangent is? Secant squared. So if you remember that if the derivative of tangent, I'll give this to you, the derivative is equal to secant squared x, please do a and b by yourself. See, what's the derivative of tangent? It's right there on the board, right? Secant what? So you know it's going to be secant squared of this, right? But then what do you have to multiply by? The whole thing gets multiplied by what? The derivative of the inside, which is 4x plus 4. And you're done. You have to do the chain rule. This is incorporating what rule? The chain rule. Nice. What about this one? What's the overall rule you have to use? The product rule. So the derivative of the first. What's the derivative of the first? Oh, it's secant squared times sine x. Then what? Plus the first times the derivative of the second. What's the derivative of sine? Hey, are we done? Yeah. Do not overly simplify. There's no reason to do anything today. Don't have to factor anything out. Leave it like that. Why do I like you leaving it like that? I've asked you this before. I can see where the steps are. I can see if you've done it right. I also like you doing the derivative of the first times the second plus the first times the derivative of the second. You can mix that up a little bit, but it just makes it harder for me to decode. So what about here? What happens here? What's the derivative of ln? What did I say the derivative of ln is? Yeah, the derivative of ln x is 1 over x. So in this case, f prime is going to be 1 over what? 2x squared. But then you have to multiply by something because the chain rule is in effect. What do you multiply by? The derivative of 2x, which is what? 4x. This you can definitely simplify. What does this simplify to? 4x over 2x squared, so what's that it simplified to? 2 over 2 over x. That would be the proper final nice answer right there. You have to remember the chain rule. Power product, chain, and quotient still are in effect, even if you learn new derivatives to begin with. Even if you learn new derivatives to begin with. What's the overall rule you have to use with this one? Yeah, you have the first one right here. First one right here. And the second one right there. So you have to do two derivatives, but you're using the product rule. What's the derivative of 2x cubed?
6x squared.
Mm-hmm. 6x squared times ln of 2x plus 1, right? Plus the first times the derivative of the second. What's the derivative of ln of 2x plus 1? 1 over 2x plus 1 times what?
2.
Exactly. Exactly. Good. You could simplify that a little bit, but I like it written like that because what does it show me? It shows me all of the pieces. It shows me that you understand all of the pieces. Yeah, if you then had to set it to 0 and solve, you'd have to do stuff to it, but right now I love it like that. I love it like that. Does that kind of make sense? How are we feeling about these so far? How are we feeling about these so far? Super exciting. I know you guys are just like, this is the most exciting. So you have cosine of what's there, right? But then you have to multiply by the derivative of the inside. You have to do the derivative of cosine of tangent, right? We need to know what the derivative of cosine of tangent is.
Yeah.
How do you find the derivative of cosine tangent? Well, that's going to be, what's that going to be? What's the derivative of cosine?
Negative sign.
Negative sine of tangent, right? But then you have to multiply by the derivative of tangent. What's the derivative of tangent? Is secant squared x. So what's the final answer to this? Cosine of cosine tangent x, right? Times, and put the negative on the outside, sine of tangent x times secant squared x. Are the parentheses super important on this one? Yes, if you don't put parentheses in, it gets really not correct. Because you're not doing a lot of you're not embedding many of them. Be very careful. This right here, the entire derivative is right there. How do we feel about this one? How do you feel about each piece of this one? Are you okay with the pieces at least? Everything will come together, I guarantee it will, and you will be able to do these as fast as you can write them down.
Can you write cosine, sine, tangent, like with the x like that, beside, like without parentheses?
I would really like you not to. Please use the parentheses. You want to drop these parentheses right here? Like cosine,
No, the
tangent.
parenthesis next to the x.
Yeah.
The
Like
parenthesis
how you-
next to the x.
Next to the
Which one?
angle things. Yeah.
Tell me where to stop.
Stop.
Yeah.
Here.
Back. Go back.
Take these out.
No.
Which ones?
You don't have any of them. Like you don't.
Oh yes,
Yeah.
I'm okay with that. You have to put the x in. You don't have to put the parentheses around it, especially when it's long as this. What about this one? Anybody do the next one?
Yeah.
Is it kind of cool?
Kinda. If I did it
Well, what's the
right.
derivative? It's 1 over.
Cosine.
It's 1 over cosine times what?
Negative sign.
Negative sine of x, right? So what is that? Negative sine,
Over cosine.
which is what?
Negative.
It's negative tangent x. That's kind of cool. Look, you take the derivative of a natural log of something and it kind of goes away. That's kind of cool. I think it's pretty cool.
I think it's super duper.
Is it super duper cool? What does that turn into? So cosine squared of x times sine x times ln of what? Tangent x? All over what? Cosine x. So that this cosine is right there, correct? So where can that cosine go?
On top.
So what do you end up with? I don't want to write in highlighter. Cosine x over cosine squared x sine x ln of tangent x. Anything cancel? That cancels, right? So that goes away. So we end up with 1 over cosine x. I don't think you need to type right now. Sine x times ln of tangent x. That's not bad. What's 1 over cosine and what's 1 over sine? Come on, what's 1 over cosine?
Secant.
So you have secant x times cosecant x times 1 over ln of tangent x. That's something.